So here consistency means what here? So consistency means this must be this, its value must be equal to this value. So here for any other d1, d2 and d3 values, this multiplication must be not equal to this. So it is said to be as consistent when d equal to 0 here. So next, for first one, d not equal to 0. For d not equal to 0, what here? D not equal to 0. Here x value can be anything. X value can be find it out easily. For correct d values given d1, d2, d3 are given, x value can be anything, a1, a2, a3, or like this also we can write b1, b2, b3, c1, c2, c3. So we can write it like this also. So here for any, if these values are given here, x values we can find it easily, and there is consistency. For this 2 multiplication we will get the answer as this one. So it is said to be as consistent. These two are multiplied, a into b, we will get a c. This is consistent. But here it is not like that. For any value of this, it can't be equal to this, because here it will be 0, it not equal to something, 1, 2, 3, and so on. It is not equal to that. So here it is not consistent. So next, for next case, for d equal to dx equal to dy equal to dz equal to 0, then the given system of equations are consistent and have infinite solution except the case of parallel planes where there is no solution. So here, if all are equal means what here? So if all are 0, this one, and also this one. For any value of xyz, this will be 0. So for any value of xyz, this into this will be 0 here. So it is said to be as consistent, but only for parallel lines have infinite solutions. Here anything, x can be infinity up to minus infinity to plus infinity. You can take anything. The answer will be 0. So here x, y, z values can be infinity. So exception is what here? Exception is, so here it can be repeated in the gate examination also, and also in the engineering point of view. It is also important in the first semester examinations of SCE. SCE means semester and examinations. It is also important for JEE mains and JEE advanced also. So this is all about consistency and homogeneous of equations. So here at the parallel planes where there is no solution. When planes are parallel like this, parallel to each other, there is no solution. Solution is no here. There is no intersection. Since there is no intersection, there is no solution for that, for those planes. So this is uh, about the consistency of equations. So next we're going to discuss about homogeneous system of equations. d1 equal to d2 equal to d3 equal to 0. So here the system of equations is called as homogeneous equations. So here if we take this like this, a1, b1, c1, a2, b2, c2, a3, b3, c3 into x, y, z equal to 0, 0, 0. This is said to be as homogeneous equation because it is in the form of ax equal to 0 here. Ax equal to 0. So it is said to be as homogeneous equation. So non-homogeneous equation we will discuss now. So here, solution of homogeneous equations is always consistent. So as x equal to 0, y equal to 0 and z equal to 0 is always a solution. So here xyz is always a solution. This is known as trivial solution here. if x comma y comma z are is equal to 0, then for any value of a1 b1 c1, for any value of a1 b1 c1, a2 b2 c2, a3 b3 c3, 0 0 0 0 0 0, so it is said to be a trivial solution, because for any value of this multiplied with 0, you will get this only, 0 only. So we will get to know as it is as follows as 0. So here it is said to be as trivial solution. Next, for homogeneous equation, if d not equal to 0, then x is equal to 0, equal to y equal to z. So here for homogeneous equation, d not equal to 0, d not equal to 0 is what here, a1, this a1 b1 c1 not equal to 0, then the thing is what here, the thing is x comma y comma z equal to 0 here is the only solution for that. So this is about homogeneous equation. Next, for homogeneous equation, if d equal to 0, then there exist non-zero solutions, non-trivial solutions also. D equal to 0, if d equal to 0, what happens? If d equal to 0 here, 0 0 0 0 0 0 0 0 0, x values can be varied, x values can be varied for different for multiplication of any value of x, you can get 0 only for homogeneous solutions, homogeneous equations. So non-trivial solutions also you will get. This is all about homogeneous equations and also consistency of system of equations. So next, applications of determinants. Following examples of shorthand writing of large expressions. Area of triangle whose vertices are x r, x r comma r. Applications means where you can use this uh, determinants. This is the application of determinants. So let's understand this. It's very important because in real life you can use these formulas to easily calculate any value or anything in the form of matrices and determinants. So here d equal to 1 by 2 x1 y1 1, x2 y2 1, x3 y3 1. So here this is equal to d equal to 0. Then the 3 points are collinear. Collinear means what here? Collinear means they are on the same line. They are on the same line. So here if this determinant equal to 0, then they are said to be as collinear. The collinearity can be easily determined by using this determinant. This is the application of determinant. So here equation of straight line passing through x1 comma y1 and x2 comma y2 is, so equation of straight line. Straight line equation is what is x y 1, x1 y1 1, x2 y2 1. 1 is equal taken in all the cases because 1 is as a and is an unitary constant. So it is taken as in the three cases. Next, the lines a1 x b1 plus these are the lines are concurrent if a1 b1 c1 a2 b2 c2, this determinant equal to 0 here. Concurrency case I will explain in next video. The video length will be increased, so I am not explaining in this video. I'll explain separately. For every question there is an answer in my videos in my channel, so please watch and enjoy my channel by watching my videos. Enjoy learning by watching my videos. Next, represents a pair of straight lines if. This represents a pair of straight lines if. This is the condition here. ABC plus 2FG, 2FGH. This is a pair of straight line. It can be a curve equation, but if it is said to be as pair of straight line equation, this must satisfy this. This must satisfy this. So this is a short method of representing this. This is a short method of representing this formula. So here AHG, HBG, HBF, GFC determinant equal to 0. Then it will be said to be as it is said to be as pair of straight lines. Next, to find variable x comma y comma z etc. in linear equations, we can use determinants. So to find the values of x comma y comma z, in the real life we may come to know that there are so many problems for solving these x comma y comma z values in the calculation of how many shades we can get for this amount of customers coming to the uh, our showroom, etc. For these all things we can use Cramer's rule and determinants applications. Determinant we can use that and solve for the solution. Some more properties of determinants. Determinants of a skew symmetric matrix of odd order is 0. So odd order means what here? Skew symmetric. Skew symmetric means what here? Minus a plus, minus a plus, minus a plus. So here 0 0 0. It will be 0. So here next Pfaffian means Pfaffian matrix is not in your syllabus. So it is for what is the value of Pfaffian matrix means of order even order. We can use Pfaffian matrix, but it's not in your syllabus, so it can't be explained here. So determinant it is Pfaffian matrix is always also there in my YouTube videos. So please check out in my YouTube section. Determinant of a skew symmetric matrix of even order is always a perfect square. So here it is always a perfect square. So in the options you can easily check which is a perfect square and tick out that problem. Tick out that problem or option. Delta n power n minus 1 where n is the order of determinant is equal to the determinant made from the cofactors of elements of determinant. So here n minus 1. So here n is what here? Row into column. Always these properties are represented only for square matrix, not any rectangular matrix or something. It is only for square matrix properties here. You will get to know that there are only square matrix problems in the IIT and JEE Mains, so it's easy for you to get the solutions easily and options correctly by using these equations. So here, where AIs are cofactors of AIs, determinant of a diagonal matrix is a product of its diagonal elements. So here D equal to 500 020 006. So here diagonal matrix is a product of its diagonal elements. So here if a diagonal matrix for diagonal matrix its product of its diagonal elements are equal to the determinant. So here it's a property of the determinant of this diagonal matrix. So here if a determinant considered as a polynomial becomes 0 when x equal to a, then x minus a is a factor of this. This is an application of factor theorem. So here this is the application of factor theorem. I will explain factor theorem in the next video. But now for that, if a determinant considered as a polynomial becomes 0, if this determinant will become 0, x equal to a, then x minus a is a factor of this. So x minus a is a factor of this. This is an application of factor theorem. Because d equal to 0, when x equal to a, x minus is factor of d. So here x minus a is factor of d here. So here this is the fifth property. I will explain this clearly in next video. This is very important property for understanding determinants. Determinants applications. The sum of the product of the elements of ith row or column with the cofactor of the corresponding elements of kth row or column is 0 provided I not equal to k. So this is the sum of the product of elements of ith row or column with the cofactor of the corresponding elements of the kth row column is 0 provided I not equal to k. This we will understand in the next video. So see here it can be easily understood in this method. So here summation j equal to 1 to n aij equal in aij of into ckj. Ckj equal to 0 if I not equal to k here. So this is the first property. I'll explain this in the next video. It's complex to understand. So you will understand in this video the basic concepts, so that you will get a grip on the subject. So next, a equal to 1 to n, aij cik equal to 0. So here summation of aij cik. Here aij means what? Here matrix element from 1 to n. Its summation will be equal to cik. Ik is what? Here k is a constant here. So here see and understand again. Kth row, the sum of the product of the element of the ith row or column with the cofactor of the corresponding element of kth row is 0 provided I not equal to k. So its summation will be equal to 0. If I equal to I not equal to k and j not equal to k, then it will be satisfied. I, here j. So it is the common property of determinant. It is very important. Uh, Keep star mark on it. It's very important for your JEE and JEE Advanced and JEE Mains also. MSET point of view also. Det of AB equal to det of A into B. So here determinant of both product of both the matrix is always equal to determinant of singular multiplication of determinant of single matrices, single determinants. So here it is shown here and proved here. Determinant of a triangular matrix is a product of its diagonal elements only. Triangular matrix is what here? This is triangular matrix. So here its its determinant is equal to always equal to its its diagonal elements product. So here it is this. This is here it is this. So special determinants. Special determinant is circular determinants. The elements of the rows or columns are in cyclic arrangement. So A B C B C A C A B. So here it will be minus A cube plus B cube plus C cube minus 3ABC. Circular means what here? Cyclic arrangement A B C B C D B C A C A B like this. A B C after B C A after C A B like this. If that is true, for that you will get the answer as A cube plus B cube minus C cube minus A B 3ABC whole of minus. So next, it is a common property 1 in 1 a b c a square b square c square a minus b into c b minus c into c minus a. So if this is there, you can directly write it as in this way in the determinant form. So here next we should find this value. If a cube b cube c cube is there, now in the place of a square b square c square, if it is there a plus a cube b cube c cube, a minus b into b minus c into c minus a into a plus b plus c, so it will be there like that. So it is same here also, it is same. Is the difference is square here, square of the second row, and the cube is same as third case. So here AB plus BC plus CA, it will be coming here. So here next, multiplication of two determinants. Determinant of A1 B1, if it will be there, so here you can directly write it as this is multiplication of individual elements. So here you can write it as like this, individual elements. It is here only I told you this only is represented here in a separate column. So next, summation of determinants. Summation of determinants is what here? So summation of determinants, delta r equal to f of r, g of r, h of r. So here a b c l m n, where a comma b comma c l comma m comma n are constant independent of r. So here summation of d delta r equal to 1 to n, equal to summation of f of r are equal to 1 to n a l. Here functions of r can be elements of only one row or one column. None of these elements other than row or column should be independent on r. So this is very important. So you can write here, if you get into summation, here also you will get into summation here from r equal to 1 to n, here from which, here summation is under which limits, here also these functions are in under that limits. So here the summation of determinants has been successfully explained here. So if you have any doubts, please let me know. Don't hesitate to contact me. I will give my email id just so you can contact there to me. So here next, determinant and integration of a determinant. So here differentiation and integration of determinant. So here determinant, integration and differentiation. So let's understand this. F1 of x, F2 of x, F3 of x, G1, these all are there here. So here you can write it as delta delta dash x. Delta dash x equal to what here? So first you should determine this first row, next plus a second row plus a third row. This will be the total determinant of this. So you can't do the total determinant if the f of f1 of x, f2 of x, f3 of x, these are all complex. That means these elements are in the values of x cube minus y cube minus z cube, like that. It's in the complex way. You can do individual derivative and then add them individual derivative of row 1, next row 2, next row 3, and add summing of them will give the answer. Next, integration of determinant will be uh, calculated from a to b. Then it will be given only to the functions which are there in the inside. So constant won't be taken, only the functions will be taken for the integration, not the constant. Here lambda 1, lambda 2 are the constants here. That is explained here now. The formula is only applicable if there is a variable only in one row or column, otherwise expand the determinant and then integrate. So here this formula is only applicable if there is a variable only in one row or column. So it is only applicable for only one row or column. There is a variable that is applicable, uh, rather that you must integrate by expanding the determinant. So here is the next, we should find